So we have some exam style questions here, and the first one is asking us to simplify x to the power of 5 over x to the power of 2. So remember earlier we said that if we're dividing, then we're going to use subtraction, and then if we're multiplying, then we're going to use addition. So what we're wanting to do here is we're wanting to subtract the powers, where we have x to the power of 5 over x to the power of 2 is equal to x to the power of 5 minus 2, which is equal to x to the power of 3. And then we can confirm this, because if we have 5 lots of x's on the numerator and then 2 lots of x's on the denominator, the 2 on the denominator are going to cancel 2 on the numerator. So we're just going to be left with 3 lots of x's which are multiplied together. But it's very complicated thinking of it like that, so it's much easier if we learn the index laws. So as our final answer here, we have x to the power of 5 divided by x to the power of 2 is equal to x to the power of 3. Now the next question is a numerical one, so it's where we don't have any variables. We have 5 to the power of 3 minus 2 to the power of 2. And what we'll do first is just write it underneath. So I've got 5 cubed minus 2 squared is equal to, and we'll separate the terms here. So we have 5 to the power of 3, which is equal to 5 times 5 times 5, which is equal to 25 times 5, because 5 times 5 is 25. And then 25 times 5 is equal to 125. And then if we do the same for the second term, we have 2 squared, which is just equal to 4. So we know that we have 125 minus 4, which is equal to 121. So therefore, 5 cubed minus 2 squared is equal to 121, which is our final answer. Now the next question asks us to simplify a to the power of 4 times by a to the power of 5 over a to the power of 3. So if I just write that underneath again, so we have a to the power of 4, which is then multiplied by this fraction, which is a to the power of 5 over a to the power of 3, is equal to, well, we can copy over the first part and just focus on the fraction first. So we have a to the power of 4 is multiplied by, and then we know that if division's involved, then the law we need to use is to subtract the powers. So we should have a to the power of 5 minus 3, and then this is equal to a to the power of 4 times by, and then 5 minus 3 is 2, so we've got times by a to the power of 2. And then this is equal to, well, we've already used the division, now we need to use multiplication. So if we're using multiplication, that means we need to add the powers together. So we have 4 plus 2, so we have a to the power of 4 plus 2, and this is equal to a to the power of 6. So therefore, a to the power of 4 times by a to the power of 5 over a to the power of 3 is equal to a to the power of 6 as our final answer. Now the next question asks us to simplify a to the power of 2 all to the power of 5. So here we have a to the power of 2, which is all to the power of 5, and that's equal to a to the power of 2 times 5, which is equal to a to the power of 10. So therefore, a squared all to the power of 5 is equal to a to the power of 10 as our final answer. Now the last exam style question we have is 14 squared plus 2a to the power of 4 over 4a squared. And the question's asking us to calculate this when a is equal to 2. So what we'll start off by doing is, if we just quickly write that underneath, so we have 14 squared plus 2a to the power of 4 divided by 4a squared. Then this is going to be equal to, well, 14 squared is 196, so we have 196 plus, and then if we substitute our 2 value into where we have an a, then we have 2 times 2 to the power of 4 on our numerator, and then in the denominator we have 4 times 2 to the power of 2. So this is equal to 196 plus, so if we have 2 times 2 to the power of 4, well, 2 to the power of 4 is 2 times 2 times 2 times 2, which is 4 times 4, so we have 16, and then 2 times 16 is equal to 32. And then on the denominator, we have 4 times 2 to the power of 2. So 2 to the power of 2 is 4. So we have 4 times 4, which is 16. So we have 196 plus 32 over 16, and this is equal to 196 plus 2, which is equal to 198. So this means that 14 squared plus 2a to the power 4 over 4a squared is equal to 198 as our final answer. So now we're going to move on to some past exam questions. So we have a good variety of past exam papers when it comes to the laws of indices. So the first question we have does look a little complicated, but we will be using a new index law. So we have the square root of 6 squared plus 8 squared is equal to the cube root of 125a cubed. And it's asking us to work out the value of a. So this question is worth 4 marks, so it is meant to be quite a difficult one. So we'll start off just by rewriting what we have. So we have the square root of 6 squared plus 8 squared is equal to the cube root of 125a cubed. And then what I'll start off by doing is just simplifying the left hand side since we don't have any variables there. So we have 6 squared, which is 36, and we have 8 cubed, which is 64. So we have the square root of 36 plus 64. And that's equal to the cube root of 125a cubed. And then 36 plus 64 is 100, so we have the square root of 100 is equal to the cube root of 125a cubed. And then the square root of 100 is 10, so this means we have 10 is equal to the cube root of 125a cubed. And then what I'm able to do at this point is I can go in 2 directions. I can either cube both sides so that we have 10 cubed is equal to 125a cubed, or I'm able to use an index law, and this is where we have, if I just write it over here in notation term, if we have the y root, so we've just got a y here and then the root of a to the x, then this is the same as saying a to the power of x over y. So I'll give an example. So say if we have the square root of a, this is equal to a to the power of 1 over 2. So this is where we have the 2 above the square root symbol, but we don't usually write that. And then obviously a is just a to the power of 1. So this means we have a to the power of a half. And if we were to use cube root and have the cube root of a, we would have a to the power of a third, because we'd have a 3 over here, and obviously a is a to the power of 1. So essentially what we want to do is take the power of what's inside the square root symbol and then divide it by whatever number we're rooting by. So if we're cube rooting or square rooting or whatever value we need to use, then that just goes on the denominator. So in this example, we could say that 125 is actually 5 to the power of 3, so it's 5 cubed. And 125 is just one of them numbers that you should recognise, because we might have used it in a few examples. So you should be able to recognise that it's 25 times 5, because 25 times 4 is obviously 100. So if we had one more 25, it would be 125. And then obviously 25 is 5 squared. So actually we have 5 cubed here. We have 5 times 5 times 5, because we have 25 times 5. So that means what we're able to do is write this as 10 is equal to the cube root of 5 to the power of 3 times a to the power of 3, which means we can then say that 10 is equal to the cube root of 5a to the power of 3. And then what we're able to do then is use our index law and say, well, 10 is equal to 5a to the power of 3 over 3. And then 3 over 3 is just 1, so we're left with 10 is equal to 5a, which leaves a is equal to 10 over 5, which is equal to 2. And then we can just quickly check this just by substituting 2 back into what we had originally. But what we'll do is we'll do it at the point where we have a value for the left-hand side. So we know the left-hand side is 10. So if we have 10 is equal to the cube root of 125a cubed, and we substitute 2 in, then that means that's equal to the cube root of 125 times 2 cubed. And 2 cubes 8, so we have 125 times 8, which is 1,000. So we have the cube root of 1,000. And we'll be able to recognise that 10 times 10 is 100 and 100 times 10 is 1000. So that means 10 times 10 times 10 is 1000, meaning 10 cubed is 1000. So that would mean the cube root of 1000 is 10. And we have 10 is equal to 10, which means that our equation holds when a is equal to 2. So as our final answer, we can state that a is equal to 2. Now the next question asks us to work out what 9.12 times by 10 to the power 10 over 3.2 times 10 to the power 4 is. So this one might look a little bit tricky, but as soon as I split this up, you should realise it's not actually that bad. So if I write it underneath, we have 9.12 times by 10 to the power 10, and that's over 3.2 times 10 to the power 4. And then what we can do is just split these into two different fractions so that we have 9.12 divided by 3.2 times by 10 to the power 10 over 10 to the power 4. And then this will be equal to 9.12 over 3.2. And then we're able to use the laws that we used earlier. So if we have something that's being divided, then that means we subtract the powers away from each other. So we actually have 10 to the power of 10 minus 4, which is 6. And then what we can do is now focus on the other fraction. So we have 9.12 divided by 3.2. And then we can say that 9.12 over 3.2 is going to be multiplied by 1 million. Because we have 10 to the power 6, which means we're timesing 10 by 10 6 times. So this is going to leave us with 6 zeros after the 1. So we're going to have 1 million. So then if we times 9.12 by a million, we'll end up with 912 and then 4 zeros. And then that's going to be divided by 3.2. And then since this is a calculator paper, we can just stick this in the calculator. Should find that we have 285 and then 4 zeros, which is 2,850,000, and that's our final answer. Now the next question is asking us to simplify 3 times a times 3 times a, and it's asking us to circle our answer. So whatever answer we have, we need to circle it. So that means we are given a slight hint because the correct answer does need to be within these 4 options. So let's write down what we have down here. So we have 3 times a times 3 times a. And then if we just group the like terms together, then that equals 3 times 3 times a times a. And then 3 times 3 is 9. So this is going to give us 9. And then a times a is a squared. So this means we have 9 times a squared. And then since we have a number and then some variable, we don't have to write the times symbol, so we just have 9a squared. And then we can check the list to see if there's 9a squared, which is the third option, so we just need to give that one a circle. So out of all the past exam questions that we have, the first 2 are actually probably the most difficult, and the rest of the questions are just very similar and very systematic to what we've been doing in the examples. So if you just have a go at these questions yourself, just to get some practice, and then check your answers in the solutions in the description. But you should hopefully realise that once you learn what the index laws are, it does become a lot easier and a lot quicker for you to calculate these calculations. But I hope you found the video useful somehow, but for now that's the end of the Laws of Indices video.